All right, so we are at PRI with Kevin and Russell from Horizon Motorsports. We have Hammerhead behind us. We've done some work with it, and we're going to let Kevin tell us what he's done over the last year, which this has taken, what, 2 or 3 years now?
Yeah, I would say at this point, 3 years of work, yeah.
There you go.
Yeah.
So take it away. We are putting some scanning dots on the car so that we can scan his new front wing setup, throw it into CFD and see what it's doing.
Yeah, so we took the initial front splitter setup and made a few recommendations, and they made changes based on that, but they used different wing elements than we had initially used in the concept. So we want to scan what they've done compared to the concept we came up with and get a more realistic picture of where we're at.
Was it just not pulling enough downforce, or like?
Yeah, the first iteration was very rear biased, so the concept helped get a lot more front aero, but we just want to see what this is doing compared to the concept. Hello.
Hello.
Fancy meeting you here.
All right, so obviously we're looking at a 1973 Pontiac TransAM that is very much not a 1973 Pontiac TransAM anymore. They scanned our front wing this morning, which has been super, super exciting to see. Verus Engineering has been super great, and they got on board pretty early in the project to make sure that we were making the right aero decisions, because a lot of this car was just built on basically a concrete floor in a one-bay garage, and they came through and they said, hey, here's the things that we think are doing well, here's the things that we think we could improve. And it's just been super, super fun to kind of explore different concepts and ideas, which we can just kind of come up with the craziest ideas possible and they'll direct us the right way. So that's been super, super fun. Yeah, so basically what we have going on here is we have our massive front splitter on the front. You can even get on front and jump on it. It's super, super strong, and it's all flat bottom from tip to tail, except about a third of the length is a massive diffuser, which that's been the most recent biggest project on this. The front end is about 90 inches wide. The rear wing's 84 inches wide. The car itself is 82. We're running 2000 to 2002 Champ car suspension, all the uprights, brakes, wishbones, dampers. And if you come over here, part of the reason why we have so much downforce is not only to go fast, but we can actually control it. Because if you look right here, we have our heave spring. So that is, once you get up to a high enough load where basically this rocker has compressed the damper, to where you can see that there's a bit of a gap for the spring. Once this damper compresses enough, that spring starts to come into play and increase the overall stiffness. So then it's a ride height control device. So when you're running tons of downforce, you get the best of both worlds. You get, in a high-speed situation, which you have like a straight, it'll start to compress both those rockers. And when it compresses both those rockers, that damper closes and it starts to hit that spring. So then when it does that, we can basically control the aero load. So then once you get to a lower speed, it's not in a factor, it's not in play. So then you get the low-end mechanical grip. So we have the same system on the rear of the car, but the thing is you don't want both those to come down, because the problem is, like, think about like a chair. Most chairs have 4 corners, but you only really need, for a stool, sometimes you have 3, and you only need 3 for stability. The 4th actually sometimes adds some complications, but the second you have 2 posts, it gets unstable, right? that's what happens with this. You go from 4 corners. The second, you only want one of them to come down because you'll have 3 points of stability, but the second both of them come down, you only have 2. It gets unstable, which we're being super careful with a video for Autotopia LA. We're doing, like, and every time, we wanted to make sure they got their video, but most of all, we wanted to, like, I knew at some point we hadn't really set up the suspension, so I knew at some point something like that would happen, which at 151 miles per hour that happened, and it went from, like, you could let go of the wheel and just let it go, to it was veering side to side like a few feet, which it literally gets, like, unstable. So I pulled in, I was like, hey, can we do, like, a quick adjustment? So my dad basically lengthened the spring gap so then it wouldn't come into play. I went to 161, stable as can be. I could take my hands off the wheel if I wanted, and it was great. So yeah, it's a super, super critical tuning device, but also one of the important factors that you can see is that we have a strain gauge up here. And that strain gauge is going to allow us to really, like, correlate the CFD results to what we're actually getting, and it'll be a super, super critical component to tuning the Aero to our car per track, because we'll be running through Grid Life Global Time Attack, and hopefully our first event is COTA for Super Lap Battle, which that would be awesome. That would be super, super fun, because that's got all challenges. It's got some low speed, some mid speed, and high speed straights, which would be the ultimate place to really put this thing through its paces. So we're obviously on the floor right now because we're looking at our massive diffuser. It's a third length of the vehicle. It's we made it out of carbon because we don't want to spend money on stuff that we know it doesn't work. So we spent the money on this because we correlated it with you guys. So I sat down, made a design up, and I sent it to you guys. You integrated it into your CFD model, and you were like, "Yep, I think it's a winner." And or like, I'm sure if there would have been a significant problem, we were also in a kind of a rush for SEMA, but what you guys helped us with is, like, we didn't want to put money into a part that wasn't going to work at the end of the day, which this thing brought our lift to drag ratio from a 1.1 to a 1.4. So, and it just makes a ton of downforce. So it's a super, super crazy piece. If you go underneath, if you're able to, you can see our exhaust dumps into it. So that also allows us to do gear changes because we can just drop the exhaust out, and then that will allow us to reach up and get to the gears a lot easier. But we still need to add the strakes. The strakes added more downforce on top of that. So yeah, then you guys are gonna kind of test these pieces here in a little bit to see what's going on, because we also talked about there's a lot of heat due to the engine location, especially because the exhaust runs near the torque tube, so we want to evacuate heat from there. So we talked to you guys about running a stainless tube all the way back to here and putting a hole, so then because you have all the air rushing by, that will help evacuate the heat hopefully from that area. Because if you just left it open with a spot that didn't have any vacuum, it's just going to work backwards on you, which is not what we want. You can see the fender gurneys. Those have been super, super helpful to fixing some of the Aero load distribution. Because a lot, like especially at the front, there's a lot of the fenders are designed to flow, and because they're designed to flow, we need to evacuate air. And we were looking at doing the louvered section, but according to you, you said that it wasn't meeting our goals, right?
Yeah. So the louvers are nice and they look cool, but in this case, they just kind of acted like a flow restriction. Mm-hmm. So like we're able to run a wide open louver, and there's just less restriction to the air exiting. So
yeah.
We tried a case with just a wide open fender vent with the gurneys, and it was a pretty significant bump.
Because it moved the load 2% forward, right?
Yeah, the interesting thing with some of these components, like the fender vents contributed to the car's total downforce, but the bigger thing that they do is shift the balance forward. So in time, if we can get the balance forward enough, you can start cranking up the rear wing more to maintain your desired overall balance, but the downforce just keeps coming up as you kind of add more front, crank up the rear,
Yeah,
total downforce goes up significantly.
for sure. Because our goal at the moment is to get 6,000 pounds of downforce at like 200, which would be monstrous.
Yeah.
You know,
Yeah,
and I
absolutely.
think we're pretty close to that right now, right?
You probably remember better than I do at this point. But
I think your number said 4,800, but
Okay.
that's not even with the new front end. You know?
Right.
Yeah, with the new front end, it probably is a bit more.
it's going to be really cool to see what the
Yeah.
new front end did.
Yeah, because the previous one, like it was 84 inches wide, and like looking at just the CFD, like center of pressure stuff,
Yeah.
it wasn't doing a whole lot. But this new stuff is it's a lot better. Well,
Yeah.
hopefully it'll be a lot better.
Yeah.
So.
The diffuser looks awesome.
Yeah, I'm really happy with the way it turned out.
What was your sort of like design process for the diffuser? I know, like I
Yeah.
think you guys covered it a little bit, but Kevin designed the diffuser, and I just slapped it into the model, and it was like, oh, this is helping you guys out a lot. And we identified that if we just added some strakes in the right spots, it was going to kind of kick it up another notch. So I was just curious how you went about the design.
So obviously this car has some stylistic components to it, so I
Yeah.
wanted to look like a certain style.
Right.
So, but it's not like a full open wheel car. So, but it's open wheel like technology. So I was trying to blend basically like an IMSA car, where you look at like the Porsches and like the new Ford GTD Mustang. I was looking at their diffusers and seeing what they were doing, because one of the problems that we had was that we wanted to follow this profile right here,
Yeah.
but that's probably not where you want to actually go up on it usually, because like if you look at the Mercedes GT3 car, it's got stages like this, not the other way around. So generally, I was just looking at a lot of Porsches too. I was like, this would work. And then basically, because we have a flat floor, I was thinking to myself, well, I want to, like, before our diffuser was modular, and it was not a constant angle. It kind of had a dip in the middle. And one of the things I was thinking was like, we got to get that out, right? And because you guys were talking about, you just generally want a constant angle. So the way that it worked in the car was a constant angle of like 9.2 degrees was what we could fit underneath. So, and because we have a flat floor, I'm pretty sure that like generally you don't want to go like over 7, right? If you don't have like a flat bottom.
Yeah.
Yeah, but because we have a flat bottom, we felt like we could go with a bit more of an attack angle. And because it's so far, we didn't want to go too extreme. So
Right.
that's like, it was just a balance of like a million things, I
Cool.
would say. Yeah.
Yeah, it's awesome. Turned out great.
Yeah, I'm really happy with the way it turned out. And I don't know, I didn't want to go forward on the design without knowing it worked. That was my main thing, because
Yeah.
it took us like 2 or 3 works of effort. Like I could send you guys photos of what it looked like, but it was like we did all wet lay,
Yeah.
which made it like, that was probably not the way to do it. Like
Right.
probably infusion would have been the way to do
Yeah.
it, because then you could have actually got it placed in time. Like you had to work, even though we had like slow hardener,
Yeah.
we had to build the top section out, and then we built the sides.
Okay.
So that's what we had to do.
Okay, we're back at the shop after scanning the Horizon car at PRI, which was a lot of fun. This is the original scan we did of their car a while back. Kind of give you an idea of the original front end design they had. We ended up sort of revising that a little bit and came up with a concept that took the original front wing elements they already had and just kind of extended them outwards so that they would be a little bit more, the span would be longer, they'd be a little bit more prominent, and it helped them out a lot with front downforce. In implementing it, they sort of took a different direction. They used some different wing elements that they had at the shop, and we wanted to scan it so that we could run analysis on that and see how it compared to the kind of concept that we gave them. So you can see here, this is the overlay of what they actually ended up with compared to the concept that we came up with. So it's different wing elements, different span. They actually went a good bit wider than what we had done. So this time we're actually going to send the scans to Kevin and let him take a crack at modeling the wing elements based off of the 3D scans. So thought that might be kind of a fun project for him. Takes a little bit of work off our plate, and yeah, I guess we'll see how it goes. I just exported the files and emailed them to him, so we'll see what we get back.